method when it comes to applying the constraint. And by using direct elimination method, you have to find out the model displacement. Then after that, you have to analyze the stress. Okay, so today my focus is to solve the problem using Excel. At the same time, I'm also going to explain how you can get the additional information like stress, strain, force, and the others. So let me copy this screen. So what the first step we do? We create the table, isn't it?
Yes.
Okay, we start with first column, element
1. Not I.
Not I,
Not J.
not A,
X I.
sun,
Y I.
Y
X J.
X J,
Y
J, cos, sine, A area, modulus, length, and then finally the stiffness value, AE over
L.
C. This is the table we're going to create. And let me guide you to draw the finite element model based on this diagram. So I'm going to take A as a node 1. So if not, there is no instruction about which elements need to be assumed as a node number 1 or 2 for the others. So you can freely start to assign any of the point as a node number 1. And then when you start, let's say you define C as node number 1 and you treat this as origin 0, 0. And then the other nodes you must read from your origin. You have to be very clear on that. So now I'm going to take point 1 as a node 1 and then I'm going to assume this as a 0, the coordinate 0, 0. And point B as node number 2. So I'm going to take the member AB as an element number 1. And point C as a node 3. And this is going to be my element number
2.
2. And this is going to be my element number. And here there is a pin support for the truss. What are the degrees of freedom? How many degrees of freedom? The truss element at each node. How many degrees of freedom? 2. Displacement X, displacement in Y. So when we have pin, this pin will restrict both of them. So at this point here, both of them, for the X we put U, U1 will be 0. For Y direction we put V, V1 is 0. These are the constraints at point. And at point B we have roller. Roller will restrict Y. So here V2 is 0. So now what you have to determine is V2, this is B. You have to know what is U2 and also you have to determine U3 and V3. So these are the solutions that our focus. So if you draw this, then you have to indicate the load is a 15. Kalau you nak pecahkan load for 2 directions, that's how we have to do, because loads and constraints apply in global coordinate system. Right. So based on this diagram, so I'll start. I have divided the problem into 3 elements: element 1, 2, and 3. Okay, let's start with element 1. Element 1, the starting node. Node 1. And the J is node 2. So I put here 1,
2.
1, 2. And then coordinate 1.
2, 3.
Coordinate X, X and Y.
Oh.
For node number 1 is,
0,
I've taken
0.
this as 0, 0. Okay. Then coordinate node J, which is node number 2. So we don't know the coordinates, right? So you have to read from the origin that you have set. X, berapa jarak dia? 150 and 250, 400 mm, and the y is 0. So
0.4
400 mm you have to convert to
meter.
okay. So what I do in Excel is I put the 10 power negative 3 e negative 3. So it auto convert for me 0.4. I'll just type 400 e negative 3 10 kuasa 3. Then it will auto convert for me. And y is 0. Y is 0. Right. Okay, to find the cos is x difference over L. But we need to know L first. Right? So if you have coordinates, L is easier to find. So in this case, you don't have to use the distance formula. Straight away you can use the length of the diagram. This one is 400. The length of element 1 is 400 mm. 4. Clear? So the cos in Excel, I need to create the formula, right? So put sama dengan equal. So to find the difference in x, first I put bracket difference xj minus, I'll just pick up the cells relevant to the xj minus xi close bracket bahagi dengan divide by L. I'll select this and then just enter. So you get 1. Cos theta is equal to 1. That means what is the theta? What is the angle? 90. Oh, see, I've already explained how you can, although finding angle is not an important when you have the coordinates, but at least you need to understand why we get, how do we get the angle? How do we get angle? So you have to first position the local coordinate system and global coordinate system. Global coordinate system is fixed. Regardless of the orientation of the truss, it's a fix. This is x, this is y, it's a fix. You stay there. But local will follow the direction of the position of the truss, the member of the truss. So here from A to I, J, right? From A to here, this is a x. And in the other one, so now the local x, global x is parallel. So the angle is 0. So cos 0, what is cos 0? 1. Yes, this is cos, right? So 1. This 0, 90, 270, 360. This is angle and this is the value. So 0 is 1. It's true. You get 1. Now to find the sine is y difference. Okay, I'll pick up yj minus yi divided by
L.
Sama, yeah. Kenapa plus sebab ini dalam scientific. You can see here the numbers is just a number format. If you don't want to look the plus all, you can change to general. Click here, you change to general. Auto, So A is 350 mm square. So apa nilai yang perlu masukkan? 350 negative, bagus. 10 times negative 6. Sum, because they're doing very fast, 350, they forgot, just put 350. Sum 350, 10 power negative 3. Careless mistake. So here I don't change, I just put 350 e negative 6. Right. Oh, sorry. Okay. Young modulus 200, 10. 10 E9. So now to calculate this,
Equal.
A times E over L equal, select A times star, select E over L.
L.
Okay. So you want to know the real values, you change the number format to the right. So in the same way, let's define the others. Okay, now take element number 2. So let's take this is I, and this is J, 2, 3. So the coordinates of node 2 is 400 millimeter
0.
0, and coordinate of node 3 X adalah 150, Y is
300.
300. So this is 150 milli, and then Y is 300. 300 milli. Now to find the length, maybe not easier.
Tak boleh
We have to
tarik
use
ke?
theorem Pythagoras, but let me use just the distance formula. So distance formula says that equals to square root. So you just type SQ, you will bring up the square root formula. So double click. So difference in x minus x2 minus x1 square root to square, but not square root square, plus difference in y minus y2 minus y1 square. Square adalah juga arrow 2, then tutup kurungan. So you get this is the value. Any questions?
L.
Okay, and these two you don't have to again type, because this is constant, right? Same. So what I do, I select, or I just select first this one 8. So you move the cursor to the corner here, plus symbol will appear. Click, just drag. Just click, drag. Dia akan sampai. Sekarang yang ini pun sama, sebab formula you dah buat, you already create the formula, you just click, drag, auto calculate. So if you try to click, double click, see it will use this. And you click here, okay, this is AE over L. It's very fast if you do in Excel. And now, here also the formula has been already created, you just drag. You just drag. See, use the difference in X over L. So I use the difference in Y. Okay. Okay, let's move on to the
3, 4.
node, element 3.
3, 4.
Only, come. Key in the details for element 3. So now only has taken 3 as a node I. If I myself I have taken 1, because we might have complication when adding up. It's okay.
Dari ke atas tu.
So coordinate 3 kita dah baca dalam elemen 2.
Three. 300.
Coordinate number 1.
0, 0. Satu. Oh tak, tu dia auto. Dia punya limited.
Okay. Okay, wait. Coordinate number 1. Coordinate J, number 1. Which one is number 1 here?
Kalau tu di tangan tu lama tu.
Right. So what is the
So
coordinate?
kita boleh guna tangan lama.
0, 0. That's why you key in 050.
Panjang.
No, just refer to the coordinate. 0. correct. It's already 0. No problem. Don't worry about the number from here. Okay, dia bagus guna Excel. Apa? Why no values? Because there is no L. So first you drag the L. Okay. Yeah, auto change.
Bentar ya, tak kira kan.
Okay, well done. Thank you. Distance formula distance. Distance of where? Which one? Distance of this. Select distance using coordinates. Formula of distance using coordinates. Tingkatan 4 ke tingkatan 3 dah belajar? Ya. Y sama dengan MX kan? Kita belajar form 3. Okay, step number 2. If I myself have done in 20 minutes,
Matrix.
this takes time. Okay, step number 2. Come on guys, step number 2 is
Matrix.
elemental fitness and false matrix. Okay. So now to find this, we have 3 elements. So we have to find K1, K2, K3, F1, F2 and F3. Right, so let's start with K1. So K1, so reference over the reference. K1 we refer to the node 1 and node 2. So the reference at each node is U1 and V1. So we start U1, V1, U2, V2. So let me tabulate in global itself. But don't worry. U3 and V3. So for another direction reference, I don't type, I just going to teach you. I have to select 6 cells. Why 6 cells? 1, 2, 3, 4, 5, 6. Okay. Sama dengan transpose. Malas nak type. Just select this one. Control Shift keyboard. Control Shift Enter. Okay, so reference dah diletakkan. And to indicate the local means the stiffness matrix, the size of matrix is 4 by 4. 4 by 4, so it relates to 1 and 2, so you have to pick just 4 by 4. And this is the elemental stiffness matrix. Okay, so what is the first, how do you key in the first one? Look at the formula. You have the formula, right?
Yes.
AEOL darab dengan cos square. So awak kena darab lah AEOL times it cos square. Then cosine. Sine. Okay, let's start. Here I just place the cursor, select the L, sama dengan AEOL. Okay, for the element number 1 times cos, select cos square. So you get it. Here AEOL times cos times
Tan fine. Dia buat rasa banyak ah.
Okay, now sama dengan AEOL times cos. I definitely going to get 0 because sine is 0 there, right? Okay. Then what are the technique I teach you? Just fill up the first 4 first. 1, 2, 3, 4. Okay, fill up here. This one is exactly same like this one. Enter. And here AEOL times
Sine square.
sine.
Square.
You definitely will get 0. So how about the second quadrant of this matrix?
Negative.
Not transpose, just negative. So you select all 4, put negative there. Select the first 4 quadrant. After you select keyboard, a keyboard here, Control Shift Enter. And we know that this 4 here is exactly same this 4 here. Okay, and then this 4 here is same. Correct. So what we're going to do here now, I select these 4 boxes sama dengan yang ini. Control Shift Enter. Right. Then select this 4 sama dengan, select the first quadrant, Control Shift Enter. So okay, it's done. Okay, not really. Now how about the force F1? F1. So look at the node number 1 first. Node number 1, look here. Node number 1. Is there any loads here? So X0, Y0. And how about node number 2? Is there any load here?
No.
No. So Y0, X0, Y0. So this is that. So elemen pertama settle. Okay, now element kedua. So in Excel, I don't repeat. I just copy, and leave one row empty. Here, Control V, paste. Of course, it all will have no values because the formula is follows. So I'll just clear. Now I need to find the position, the location. Element number 2, node 2 and node 3 means that indicate that our local matrix will be positioned here. I need to find row 2 here. Mulai daripada U2 up to the main view. And this one. So these are the position of stiffness matrix. Element 2 in the global matrix.
Kan dalam test nanti kena tulis balik dalam kertas ni.
Ya, ubah sini pun boleh. Lepas tu kena salin balik dalam kertas.
So tak boleh PDF kan?
Tak boleh PDF. So then you ubah sini, ini K2, F2. So the formula is same. The first cell is environment. Come here.
Tengok masa kan. Benda tu tulis kat kertas kan. Seorang yang buat
Fill up the first quadrant. First 4 cells.
Seorang tu kena betul lah. Seorang tu salah pun salah. Ha? Tak tahu lah kalau nanti orang tu buat.
Okay. Sama dengan, put sama dengan, equal, go to the table over there, scroll up, use the mouse, okay, sama dengan, go to the table, okay, select this value. Okay, now look at the row number 2, element number 1. Select this one.
Tengah.
Okay, times time is simply star. Shift number 8. Okay, then times with cos. Take cos values of row number 2 here.
Cosine.
Square. Shift number 6. Lower. Type 2. Okay, enter. Next one. Next is here. Go to here. Okay, sama dengan. Again, take the AUL value. Not element 1, element 2. Because now we are doing for element number 2. Times cos times sine. Enter. Done. Okay, now you have to fill up this. Equal. Don't repeat the formula. It's exactly equal to this. Select that cell. Enter. Okay. Okay. Next one. Equal. Select AUOL. Go to the table. Element number 2 times sine square. Enter. Okay, well done. You can go to your seat. Thank you. Normal selection, just normal selection. No, not like that. Normal selection. I like that.
Cuma tak pernah guna Excel.
Escape. Select.
Sama. Ada
Okay.
coding dulu sama.
Negative.
Transpose.
Negative. Okay. Select the first four. Okay, first four. Okay. Control Shift.
Masuk ke
Enter.
meja itu.
Okay. Autofill. Okay. Thank you. Go. Miss, come here. You try. Select all of them. Equals. Select. Okay. Now Control Shift. Enter. Well done. Okay. Good. Brother, please you. This one. What will you do here? What do you think? Select sama dengan
Tak. Okey dah.
equal.
Nampak lembab. Nampak lembab.
Select that
Kata perempuan
first
sebelum
four.
kita make up.
Okay, Control Shift.
Muka dia pusing.
Okay, done. Thank you. Well done.
Ah. Diam pula.
Now, force matrix for element 2.
Aku jadi macam buai
So how we
ambil colour pink ni.
find out F2?
Buai.
Now you have to look at the figure. Go back to the figure. At node
There
2,
was
is
a
there any
pink
loads?
photo tu.
Okay. So what you have to gain? X0, Y0. U2, U2 indicates X. V2 indicates Y. And now, how about the node 3? There is a load at angle 30 degree. So you have to find two components of it, X and Y. Okay, I'll teach you. Right. So now we have look at node number 3. We have 15 cos 30 degrees to find the X component here. Then 15 kilo Newton sine 30 to find this Y component. But how to do in Excel? Excel by default the angle unit is radian, but calculator in degree, right? So first I need to okay, let's see here. 30 degree. How to convert to radian? Times with pi over 180. Okay, so this is the value. Now
Tulis pi.
X direction is 15,000 cos. Select this. Enter.
Sudah.
Okay. So here 15,000 times sine. Sine I just type SIN, then the function will come out.
Double click.
Yes, double click.
So yang 0.5 kenapa?
Sebab Excel default unit untuk angle adalah radian. So sebab tu saya convert. In calculator you don't have to convert. Cuba guna calculator, tidak sama kan? Kalau tak you kena pergi sana option, dia banyak benda lah nak kena tukar. Macam kena tukar. Yes. Mungkin saya tahu ada yang lebih hebat daripada saya guna Excel. Okay. So now we done for K2 and F2. So let's copy this and I'm going to put here. Since our mate
Mesti lama ni.
he has selected node I is 3,
Kita buat
node J is 1. Okay, so we might face some.
Huh?
I don't know how. For me, it's okay. For your understanding, so let's see whether you can follow or not. Okay, so saya tukar yang ni adalah 3.
Otak.
Ini 3. Yang ini semua I'm going to
Tadi elemen
make it
tu.
fill and so I'm going to select which one based on the here. So see carefully, node I is 3, node J is 1 for element 3. So the reference is U3, V3, U1, V1. Faham eh?
Yang ni yang tadi kita cakap susah sikit nanti sebab dia
Bukan position dia, bukan sikit formula sama, position dia. Kalau you pilih 1, 3, it's easier. U1, V1, U3, V3.
Yang one.
It's not tough, it's easier. Okay. So now the reference is going to be U3 here first, U3, V3, then U1, V1. So means that this box is here, this box is here, and got it? Now your formula K times cos square will be here. Okay, cos theta, sin theta is here first. In here first. Clear or not? Yes, that will be the first four quadrant. First 4 cells will be here. Faham ke tidak? Faham eh? Okay. Right, so I'm going to select the position first.
Kalau tak hapuskan ni.
So this is going to be the matrix 4 by 4. But as per the formula, since we have defined I as 3, so we'll start here first. Here. Okay. So first take the AEOL value times with cos square. So now you know what? Then here is AEOL times cos times sine. Good. So here same like this one. So here same like, not same. AEOL times with sine. So now the rest will become easier. So this part is just negative value. Just turn into negative values of the first 4. Control Shift Enter. And here this one. Sama dengan Control Shift Enter. And here sama dengan select this one, Control Shift
Kau terbalik.
Okay, for F3 is U1. Okay, here and here, right? Okay. See, I did it wrong. V1, so sini pun U3, U3. Okay, wrong. I did wrong. Okay. This one supposed to be here. So this is the location. Apa? Sebab untuk K3 based on that definition, U3, V3, U1, V1. Maka dekat sini pun U3, V3, U1, V1. So the first one is the position is baris U3, V3, kolom U3, V3. So dekat sini. Maka kalau nak sesuaikan dengan kita, the location is here. Baris U3, V3, kolom U3. So now this is going to be this negative kind of this. Okay, and this one is same like
Close loop.
enter, and here same like
Right. Close.
okay. Sorry guys. Okay, and now for force F3. So look at note number 3. Note number 3, the loads kita dah cari dekat sini kan. Do we really need to put again? Note 3, no need. Just put 0, 0. And look at note number 1, 0. That's it. Right. So step number 3 is global stiffness. Global stiffness matrix and global force matrix. So what we're trying to do is we're trying to arrange the formula as K times U sama dengan F. Okay, jadi saya nak copy this one. Ini letak sini. So this one is no longer K3, Kg, global. And this I clear all this. This is F. Okay, right. Right. So now to fill up this, kita tak perlu buat satu-satu, Excel very fast. Very fast. Select 6 by 6, all of them. Select. Please, at the back, clear. Sama dengan, okay, kita nak tambah K1 tambah K2 tambah K3, go to the K1. Jangan pilih 4 ni saja. Select all 6 by 6 walaupun no values in the other cells. Okay, then tambah, you have plus sign. You see, look at the here, look at here. Then now I'm going to select K2, tambah, add, then finally K3. Okay, that's it. Then keyboard, Control Shift, Enter. Okay, auto. Right? Kalau kita buat manual, we have to very careful with the row numbers and column numbers.
Tambah
The same way, select all of this, sama dengan F1. F1 adalah ni tambah dengan F2 tambah dengan F3. Kontrol
Kamu
shift
tak kata apa?
enter, dah dapat. That's it. So
Ini
dah
kita
dapat.
buat.
Okay, terus jump ke step 4. So which one you want to use? Penalty or direct? Penalty, ya?
Both.
Okay, I'll give you ball, you kick. Okay,
Both.
let's start.
Dua lah.
Step 4, applying the constraints. So using penalty method. Okay, so now we have to identify what is the constraint. Constraints, we know that the constraints are U1, V1 and V2. Okay. U1 sama dengan V1 sama dengan V2 sama dengan kosong kan? So now I'm going to copy this, all of them. The copy when you do in manual is salin smoother. Okay, then I clear all of them here because I cannot change one cell. If I change, it will say so I'm going to rewrite, enter, then drag saja, drag saja. Ini tulis balik. Ini sama dengan ini. Okay, so I dah rewrite. So now I'm going to apply the penalty constant. Kalau nak apply penalty constant, what you need? You need the ball, right? So the ball is, what is the value you're going to use?
1
time
E to E.
1 E30, yeah?
30.
Okay, so this is the penalty constant that we're going to use.
Bukan E20 eh?
20 pun boleh, 40 pun boleh, semua boleh. No worries. As long as it's a large value.
Oh.
Okay, so I got the balls in. So here I'm going to write down the constraints. I'm going to write down the constraint just to guide me, just to guide me the solution. So constraint saya dah tahu U1 kosong saya masukkan, and then V1 kosong, V2 kosong. So saya letakkan this as a guide only, right? Okay, if you want to apply penalty constant, first we look at the constraint U1. U1 refers to the U1 row here. So you have to find the cells U1 is here. So whatever value is there, just remove, delete, gantikan dengan penalty constant. Okay, I've replaced here. Same times go to the load matrix here, the same row U1, whatever value is there, just remove, delete, sama dengan penalty constant darab dengan constraint. Enter. So this is how we need to replace penalty constant with referring to the constraints. Okay, now the second constraint is V1. So V1, look at the row V1 and column V1. So the location is here. So what you have to do? Replace. Whatever value is there, just delete, replace dengan penalty constant.
Oh doktor, so kalau nak guna kaedah penalti, kita kena ada constraint lah untuk ganti yang tepat.
constant. Penalty constant.
No, I mean,
Yeah, based on constraints. Yes.
Ah,
Based on constraints.
so no constraints. So
Kalau tak ada constraint, kekalkan saja matrix. Remain the matrix. Right, so go back to the load matrix. Delete sama dengan penalty constant times constant. If let's say U1 instead of 0, we said U1 is allowed to move just 5 cm. So the constraint will be 5 cm. So 5 cm is, yes, okay, the value will be changed. Sebab penalty constant darab dengan constraint. But what we given here is 0, 1. So who going to do for V2? Tadi dua-dua dah bangun. Brother, come. You.
Apa dia? Itu memang kaedah penalti meter. Memang tu.
Okay, so
Tak
kita
boleh ni satu
identify the
kosong.
location.
Yang penting besar, nilai itu besar.
Delete. Sama dengan enter. Same way, we have to delete. Sama dengan penalty constant darab asal times constraint. Right, well done.
Betul dia dapat mana dia?
Back.
I don't know.
So penalty constant, applying penalty
Constantly
method,
only.
size of matrix will remain same. So once you have applied, done, we can jump to the step number 5, solve. How to solve? To find U is equals to A inverse times with F.
Macam mana dapat ni?
So now let's find the K inverse. K inverse, the size of matrix is 6 by 6. So we have to select
Dah nak ujung-ujung
6 by 6 cells. See, as you select, here will be changed. So that you can
Kita buat
make it
tak
as a
sampai
guide.
kat sini. Itu
6
jauh
rows,
kan.
6 column.
Sampai step 3.
Then sama dengan
global matrix pun tak habis.
you have to call the function inverse matrix. So just type M inverse. Yeah, this one.
Bukan ada pause-pause.
M inverse. Double click. Select this matrix that we're going to inverse. Then you select Control Shift Enter.
Aisyah.
Okay. Repeat. Balik. Masa ada lagi. So to find inverse matrix, first we have to know the size of matrix 6 by 6. So you select 6 by 6 empty spaces here. Okay. Sama dengan M inverse, just type M-I-N. So function ni akan keluar, pilih function ni double click. Select the matrix here and then Control Shift keyboard enter. So this is the inverse matrix. Belum kita cari inverse dulu Kita dah cari inverse So formula says to solve U, if you want to solve U, U is sama dengan K inverse, which kita dah cari dekat sini, darab dengan F. So when you solve, what you get? You will get the values of daripada U1 hingga V3. So let me put first here. Okay, we are going to solve this. So first I select 6 by 1 cells. Sekarang saya nak perform matrix multiplication. Okay, K inverse. So matrix multiplication punya function adalah you just type MM keluar. Matrix multiplication, double click, select K inverse, comma, darab dengan F. Jangan pilih F ini F you dah modify. Okay. Keyboard Control Shift Enter. So jawapan dah dapat. Yes, please.
Betul. Kalau penalti kan, dia kan kena dia beri tak constraint dia strict semua tukar kan.
Itu direct. Direct elimination method, you ganti satu, yang baris tu semua jadikan kosong. Kelas lepas ni.
Ada.
Zero, huh? It's not very significant. Here, zero. So it agrees with our constraint. It's taken as zero. So the answers are U2 3.143 times 10 power negative 5 meter. U3 0.0012 meter. So like that you have to write your answer. So now I'm going to teach how we're going to find the extra information. What you need here is first you need this information element coordinate kita this. Copy all of them, put here, then I delete this one. Delete all of them. So here no longer X, sebab kita dah ada jawapan kan. This is U I V I U J and this V. So let's say you want to find the elongation. You want to find the elongation. So that I need to do remember interest, right? So this is I and so the output you get, for instance, these are the output solution. This is UI and this is U. So now we have to combine these two and translate into here as a U prime I. Yeah, I. Thank you. And here, U, J, and we translate here into U prime. So because this is two force member, now you have to find what is this value based on your findings. So you have this elongation can be found easily. Elongation is Uj prime minus Y. So we can simply use the Excel. First, just transfer all the info here. Just drag, you can copy all from the table. So now I have to translate. Yang ini jawapannya apa sini? Based on the note numbering here, note 1, U1, V1. So U1 is here, V1 is here. Here, 2, note number 2, U2, V2. U2 is here. V2 is here. So now I'm moving to the element number 2. Element number 2, node 2 and node 3. So here U2, V2. Okay. here element node 3 is output. For element number 3, node I is 3, so the first one is U3 V3. So I just transfer the information from the solution. Then 1 is here. So before we find the elongation, we have to first find what is the UI prime, and then UJ prime. So UI prime is sama dengan take UI times with cos plus VI times with sin. UJ, take UJ times with cos plus VJ times with sin. Okay. So the rest you don't have to repeat, just drag. Perfect.
Tu formula dia.
Formula dia. Dalam nota ada Dalam nota ada. Okey, baru you boleh cari elongation. Bila ada elongation, you dah boleh ada strain. Bila ada strain, boleh dapat
banyak sel.
stress. Bila ada stress, you boleh dapat force. Okay, bagaimana nak cari elongation? UJ minus Y. So equal UJ minus Y. So just write saja. Strain elongation divide with the original length. Right. Yang belakang boleh follow atau tidak?
Boleh.
Don't be lost, Okay, stress
Times E.
strain multiply with
E.
Young modulus. Okay, right. So yang ni tensile sebab positif Yang ni negatif compressive stress. So force stress equals to F over A. Maka force adalah stress times A. Stress times with
Sudah settle lah.
So, bila soalan minta, contoh dalam soalan ni dia minta apa? They ask you solve the nodal displacement then analyze stress in member BC. Member BC refers to your assigned element 2. So just take the stress of element 2 here. Okay. Negative 30 mega. Yeah. And then yeah. 3 Pascal. Okay, so that's all from me today. Thank you very much.